Objective 8.7, to be able to solve logarithmic equations. Solve the equation and check for extraneous solutions. Here we have 3 times the log of 5x equals 12. So again, what we want to try to do is get the logarithmic equation alone. So get the log alone and evaluate from there. So our first step would be dividing by 3 on each side. So we have log of 5x equals 4. Now, we have to get x alone, and that's right here in our answer argument. So again, we want to think about what logarithmic means. Log means what exponent goes on the base. Well, what base are we working with here? None is written, so we have to remember when that happens, our base is 10. So you might want to write that in. So what exponent goes on 10 to give us an answer of 5x? And here's the clue for our exponent. So we have 10 to the 4th equals 5x. We know 10 to the power of 4 is 10,000. In order to solve for x, we would have to undo that multiplication, so we would divide each side by 5. So x equals 2,000. Again, we have to check and make sure this is true for the logarithmic equation. So we're going to substitute that into the original. So here we've got some multiplying to do. 5 times 2,000 would be 10,000. And here we could evaluate this in our calculator as is. We could do 3 times the log of 10,000 and make sure it equals 12. We also could just do the evaluate the log of 10,000, which is 4, and multiply by 3, which checks out and gives us 12. So the correct value for x for our equation would be 2,000. Again, when solving your logarithmic equations, undo the equation as usual using your properties of logarithms. In order to undo the logarithm, use your definition of the exponential. Remember, they're inverse operations. So what exponent goes on the base to give you the answer argument. And at the very end, always check for extraneous solutions. Make sure the value that you're solving for your variable really does work for the function that you're given.